In the last two sessions, we discussed about what is software testing, the importance and significance of software testing, the different stages in which we could perform software testing. So we understood it is not in the beginning or it is not at the end. So it can happen even in the intermediary stages. Okay. So software testing could be done during design and coding, which we call as development testing. This was discussed in session 1. Software testing could be done after the software product is complete. So we call this as release testing. Software testing could also be done when the product is given to the customer and customer is using the software. So the customer himself is a tester in this case. Okay. So that is user testing. So we had understood this in session 1. Okay. Next, in session 2, we took up unit testing under development testing. So development testing was the topic of discussion in session 2. So we took up unit testing. We understood what is unit testing. Testing the smallest component, the smallest unit in the software or system. Okay. Also, we understood various aspects of unit testing like test cases, the importance and significance of writing a test case. We also understood we cannot write test cases in an exhaustive manner, meaning that we cannot cover all the possible inputs, we cannot cover all the possible scenarios. Okay. Now the thing is we should be selective, and when you are becoming selective, so we need to adopt a strategy which ensures that majority of the flaws or issues in the system can be identified. So we understood what are the strategies we need to take up, we need to accommodate for choosing test cases. We also understood the difference between black box and white box testing, where our perspective about the system is different. Okay, so in black box testing, we consider only the functionality of the system. Okay, we are giving an input, whether the system is taking that input, processing it as per the expectation and giving the desired output. So that is what we verify in black box, meaning that we are not concerned about the internal details of the software. Now coming to white box testing. So white box is the opposite of black box, meaning that we are not only concerned about the functionality, we are concerned about the internal coding details of the software or the internal details of the system, and we check whether it is behaving as per the expectation. Okay, that was white box testing. We also understood what is equivalence partitioning, because just now I mentioned we cannot have an exhaustive set of data test cases. That's not possible. So you need to become very selective, and selective sampling through equivalence partitioning. How it is done, we understood that in session 2. And we had a brief recap, introductory part with respect to what is component testing. So this is what we had covered in session 2. Now coming to session 3. Okay. So in session 3, we will continue with respect to component testing with much more detailing. We will try to explore different aspects of component testing with examples. Now, what is a component in a software? So we had understood that in session 2. Okay. So in the previous session we had seen what is a unit, the smallest part, okay, smallest function, the smallest routine in the software. So few functions, few routines, okay, combined together may become one component. Now which function, which unit, which part you will be combining? So obviously it goes without saying, the ones which are related. For example, 4 functions are related. Function 1, 2, 3, 4. As you can see in this example, 4 functions are related to one another. They are doing some common activity. Okay, they are doing something that is common, achieving something together. Okay. So now that becomes component 1. So we will integrate those small 4 units and that will become component 1. So like that you can have multiple components, component 2, component 3 up to component n. So all these components combined together, will become a software or a system as a whole. Okay. Now, so as you can see in this graphical illustration, components are not independent units. So you can see component 1 should interact with component 2. Component 2 should interact with maybe component number 10. So depending on how the design has been planned, how the coding has been done, what type of behavior is expected from the software. So a specific component may need to interact with a different component. Okay. Now how component interacts with one another? So component interact with one another through what we call as interfaces. Okay. So you can see in this graphical illustration, component 1 and 2 are interacting with one another using unidirectional interfaces. For example, component 1 is interacting with component 2 using interface 1. I have abbreviated it as IF1. So component 2 is interacting with component 1 using IF2, interface 2. So the bottom line is components are not independent units. They should interact with one another to achieve the desired outcome. Now we are in the testing part. We are not into designing a component or coding a component. We are in the testing module. Okay. So the point here is how you will test whether component 1 is correctly interacting with component 2 as per the expected behavior. How exactly you are doing it. Okay. So if you want to check whether component 1 is interacting with component 2 as per the expectations, you need to check the interface. Okay. Because interfaces are the points which will be used to transact the data, which will be the points of communication between different components. So the thing is, you should check for the proper working of the interfaces between the components. Okay. Now, how exactly interfaces will be tested? What type of possible errors can pop up in an interface? Okay. So that is the type of interface errors. So that is what we will be discussing now. So the first type is the parameter interface. Okay. So as already mentioned, component 1 may pass a data value to component 2 as a parameter. Okay. For example, if component 1 is sending a value x equal to 3 to component 2. So now this x equal to 3 is the parameter. Okay. So x equal to 3 is the parameter. We check whether this value x equal to 3 is passed correctly from component 1 to component 2, maintaining the integrity, meaning that the value of x should not change during transit. Okay. That is, x equal to 3 was sent by component 1 and it should not happen like x equal to 5 was received by component 2. So data integrity should be maintained, and that is what is verified during parameter interface testing, which is a type of component testing. Okay. Now one more possibility is there, the second type of interface that we will be testing. So it is called as the shared memory interface. So shared memory interface. So what is a shared memory interface? Okay. So one more possibility can be there. So just now we understood component 1 is directly passing the argument or data value to component 2 using interface. Okay. There is a direct connection between component 1 and component 2. One more possibility as part of the design. So we may not have a direct connection, we may not have a direct interface between two components. So there may be a possibility like component 2 and 3 interacting with one another through a section in the memory called as shared memory. Okay. So this is a shared memory here. Now what is the significance of this shared memory that I have written here as a graphical illustration? So shared memory is a common memory shared between component 2 and component 3. Okay. So component 2 and component 3 are using this memory, this part of the block that you are seeing. Now if component 2 wants to send something to component 3, okay, so as you can see there is no direct connection So it is through what is called as shared memory, meaning that we will assume component 2 wants to send a hello message to component 3. So what component 2 will do now? Okay, there is no interface as a direct connection here. So component 2 will write it in the shared memory. Okay, so hello message is written in the shared memory, and from the shared memory component 2 will read it, meaning that component 2 is writing hello message to the shared memory and component 3 is reading it. Okay, so it will read it here. So hope you understood what is shared memory and how exactly it is used by components for interaction. We also understood there is no direct interface between the two components in case of a shared memory being allocated. Okay. Now the question here is, what should we check here? What should we test? So obviously we should check that the shared memory is being properly utilized by the components for interaction, meaning that component 2 is writing hello message in the shared memory. So we will check, okay, so this block of the memory is being correctly accessed by component 2 and this data is being written there. Okay, so it is put in this shared memory as per the expectation. Okay. So the same is applicable with respect to component 3. So we check whether component 3 is correctly reading from the shared memory. Okay. So this was the second one, the shared memory interface between the components. So now we will go into the third one, the third type of interface that can exist between the components. So third type of interface is called as procedural interface. So a procedural interface, what is procedural interface? So we'll expand this block. So we'll expand this software. To include few more components, so that we get a better understanding of what is procedural interface. So in the previous cases I just had 3 components, I'll add a few more components here. I'll add component number 4. Okay, so maybe one more component, component 5. So I have 5 components in this example. Now consider a program to add 2 numbers. The procedure for adding 2 numbers is in component 5. We will assume like this. We have a procedure here. What is this procedure? So it's a procedure which contains logic or the piece of code using which 2 numbers can be added. Okay. So procedure is there in component 5. Please understand. Procedure is there in component 5. And component 4 wants to utilize this procedure to get the results, meaning that component 4 is having 2 numbers 2, 3, which are parameters. Okay, so component 4 is having 2 numbers 2, 3, but procedure for adding these 2 numbers is not present in component 4. Okay, it is just having the raw data, that's it. Okay, it wants the results. Now what component 4 will do in this specific case? Okay, so component 4 cannot perform the addition. So what it will do? It will call the procedure. Where is the procedure? Procedure is there in component 5. Okay, so component 4 in this case will call the procedure that is there in component 5. Also, when calling the procedure, it will send the arguments. So these arguments, the procedure will execute, it will generate the results, and results will be sent back to component 4. Okay. Now what should be your observation in this case? So your observation should be that procedure is in a specific component, okay, and this procedure is being called by a different component. okay, for a specific action. So this was procedural interface. Okay, so this was the third one, the third type of interface that can exist between two components. Okay, so an interface which will be used to call a procedure that is existing in a different component. So this was third one. Now coming to the fourth one, the fourth type of interface that can exist between components and that should be tested. Okay. See, we are not only studying about the types of interfaces between the components. Okay. We are also understanding what should be tested. For example, just now in the previous discussion we concluded, we understood what is procedural interface. Now what you should test here? So you should test whether the call, okay, is happening as per the expectation, whether component 4 is calling the add procedure in component 5, whether it is calling it correctly. That is the first thing. So second thing is whether the function or the procedure is receiving the arguments 2 and 3, okay, as per the guidelines, as per the expectation, as per the expected behavior, whether it is receiving the arguments. Okay, so these things should be checked, should be verified in procedural interface. Okay. So the last one, the fourth one and the last one, so message passing. So message passing interface. Now what is message passing interface? It is typically like a client server environment. Okay, like for example, so I will take an example where I have a component, for example component 4, component 4, okay. We will assume one more component is there, component 5. We will also assume component 5 is connected to the DB, database. Okay, it is connected to the database. Now component 4 wants to know few details of Anil. Okay, so we will assume Anil is a student, all his credentials are stored in the database. His credentials like name, mobile number, address. Okay, so all these details of Anil is stored in the database, and please note this database is accessible only to component 5. Okay, so component 5 as an interface to database, but still component 4 needs those details. It needs the full name of Anil, mobile number of Anil, address of Anil for computation purpose. Okay. Now in this case, what needs to be done? What should be done? So component 4 will send a request. Okay, will send a message. It will send a request. Request for what? So details of Anil. So now what component 5 will do? So component 4 has sent a request that it needs the credentials of Anil. So component 5, it will take this request, and if it is a authenticated request, it is a valid request, component 5 will access the details from the database. It will access it, it will process it, arrange it in the form of a response. Okay, it will arrange it in the form of a response, because in the data form, in the database, the data is stored in a different format, and when you are sending it from a component to a different component, so the format will change. Okay, so the component 5 will process it, arrange the data in a way it could be sent across the interface to a different component, and the details of Anil will be sent as a response. So typically this was an example for message passing interface where we understood a component is sending a request for something. That request was taken by another component. The request was processed and a response was framed, and it was sent back to the source component. Okay. So this type of mechanism is called as message passing interface. Now once again, as I told you, just studying what is message passing interface is not the objective of this module. Okay. What should be tested here? What you will be testing here? So you will be testing whether the request reaches the intended component. In my example, it is component 5. Whether the request reaches the component correctly. Okay, so that will be verified. Whether the response that was generated reaches back to the source component as per the normal expectation. So all these things will be tested in message passing interface. So just to have a recap of what we are discussing in this specific session, we are discussing component testing, okay, which is a specific level in development testing. Development testing was a stage in is one of the stages in software testing. Okay, so we understood what are the different types of interfaces that can exist between the components in a software. Okay, interfaces are of different types, so obviously the way the interfaces are working are different, and if that is the case, the way in which you test the interface should also be different. Okay, it's like a chain sequence. Okay, so these were the different types of interfaces. So next topic of discussion is the errors. What errors you can expect from different interfaces. Okay, so this is based on our previous experience of working with these type of components, previous experience of doing testing. So testers have identified few common type of interface errors that usually occur. Okay, we'll try to have a brief of it. So interface errors. So what are the different types of interface errors that can occur? Okay. Now as discussed, so we saw in this case okay. Now in order to understand the different types of errors that can possibly occur, I'll take the same example. We have few components. So this is my component 1. Okay, so this is my second component. So component 2. Okay, one more component, component 3. Okay. We will also assume that between component 1 and 2, so we had an interface. I'll label it as IF1. Okay, meaning that if component 1 wants to interact with component 2, it is through interface 1. We'll also assume that between component 1 and component 3, there is one more interface. We will call it as IF2, that is interface 2. So it goes without saying that if component 1 wants to talk with component 2, it should use interface 1. It should use this. If component 1 wants to talk with component 3, it should use interface 2. This is the design. Okay, this is the design that has been planned. Okay. And if everything goes as per the plan, so there are no issues, there are no errors, there are no bugs. Now what are the possibilities that can happen in this case? Okay. So one possibility here is what we call as interface misuse. Misuse, where a component is using a different interface for communicating with the component. To become more specific, so if component 1 wants to talk with component 2, as we understood, it should invoke interface 1. Okay, it should invoke this, but component 1 is invoking this interface 2. So intention of component 1 is talking with component 2, for which it should invoke interface 1, but it is not doing it. Instead, it is invoking a different interface. Okay, meaning that instead of talking with component 2, it will talk with component 3. Okay, which is not what is desired. Okay. So this we call as interface misuse. Okay. So this is one type of error that commonly occurs in interface testing. Okay. The next type is interface misunderstanding. So we will utilize the same example, interface misunderstanding. The second one, what is interface misunderstanding? Okay. For example, I start speaking in German and you do not know German. What will be the outcome? So there will be a failure in communication. Okay. So communication will not be successful. So following these lines, what is interface misunderstanding? Okay. So component 1 is sending a data in a specific format, and component 2, maybe 2 or 3 is expecting the data in a different format. Okay, to put it in simple terms, component 1 is sending a value x equal to 3. As you can see, x equal to 3 is an integer, but component 3 is expecting it as a float value. We will just assume this as an example for clarity. Okay. So component 3 is expecting a float value, but component 1 is sending an int value through the interface. Now what will be the consequence? So obviously it will be a misunderstanding, or it may be an error, or it may result in some unexpected situations. Okay. So these type of situations we call as interface misunderstanding, where a component is expecting the data, a parameter, an argument, a message in a specific format, but it is being given or delivered in a different format, okay, a different way. So this is the interface misunderstanding. So to take up one more example, if you assume component 3 is doing bubble sort, okay, so component 3 is, it is doing binary search. We are aware of what is binary search, and the prerequisite for binary search is the data should be sorted. Okay, so if component 1 is sending the data in a sorted order, okay, search will be successful and it will go as per the expectation. What if component 1 is sending the search elements in a unordered way? Okay, once again it will be a flaw here. So in a nutshell, interface misunderstanding means, okay, a component is expecting the data in a specific format, in a specific way, but the source component is sending it in a different way. Okay, that is component misunderstanding. This is one more common error that can occur between interfaces between the components using the interface. Okay. The third one. So third one is timing error. So what is a timing error? Once again, we will utilize the same example. Okay. Now we will assume that component 1 is having a sensor which is giving temperature and humidity value. The same is being received by component 3. We will assume like that. Okay. So component 3 should get the value, data value, maybe at 10 AM. Okay. So this is the plan as per the design. 10 AM. The sensor in component 1 should give the reading of temperature and humidity to component 3. Okay. That does not happen. It is giving it at maybe 10:30, 11 o'clock, 12 o'clock. Okay. So the point here is the data from a component is not reaching the intended component, okay, within the specified time. Okay. So these are real-time systems where data should reach the intended component or destination. Okay, so as per the plans. If not, the data may lose its value. Okay, it is like giving a question paper after the examination is over. So if the exam is from maybe 9 to 12, 9 a.m. to 12 p.m. So you should be given with the question paper at 9 o'clock. Then only the question paper will have the value. Okay. So you're getting the question paper maybe at 12:15, 12:30. So it does not serve the purpose. Okay. So it is called as a timing error. Okay. So data in real time should reach the component. Okay. So as per the expectation. Okay. So within the desired window period. If not, the data may lose its value, the data may lose its significance, okay, or it may result in some unexpected behavior in the system. Okay. So this is timing error. So the question here is, we understood what is component testing. Okay, basically smaller units combined together will become a component, and components are not independent units. They should interact with other components to achieve the desired outcome as part of the system or software. Okay. And the major aspect in component testing is testing the interface, because interfaces are points of communication between the components. So if you want components to interact correctly and give you the desired outcome, you should check the interface. So interface will play a major role in component testing. That is what we understood. So we understood the different types of interfaces that can exist between the components, and just knowing what are the different types of interfaces is not sufficient in this module. This module is exclusively talking about testing. So how to test those interfaces? What should be tested? Okay. What should be verified? So we understood that. Okay. Also we understood a few common errors that typically occur between the interfaces. So we understood that. Now the next question is interface testing in component testing. Okay. Is it a simple job or a challenging job? Is it a complex task? Okay. So the answer to this question is, it is a bit challenging, it is complex. Justification is because of uncertainty here. For example, see, as you can see, different components are connected to one another through interfaces. See, a component as a whole may work correctly. For example, component 2 has one single unit. Component 2 has one single unit is working correctly as per the expectation. But immediately when component 2 starts interacting with component 3, its behavior may change. Okay. It may not work as per the expectation. So please try to observe here, because of interdependency, okay, so interrelation between different components, predicting or verifying the correctness is difficult here, it is challenging. Okay. Also, a fault in one component can result in unwanted consequences in other component, because already I mentioned it is like a sequence of chain. Okay. Any issues with one component can result in a problem with other component. Okay. So that is the reason checking the components and its corresponding interfaces for errors and flaws is a challenging task. Okay. Now, if you are doing component testing, if you are doing interface testing, how you need to, how you should strategize your testing, because as discussed in unit testing, we cannot have a exhaustive set of test cases here. Okay, you cannot test all possible scenarios. You cannot test for all possible inputs. Okay, it is not feasible. Now you need to strategize, you need to come out with a strategy which ensures the samples that you are using can give us the most appropriate and accurate results and is a representative of the overall system. Okay. Now how it can be done? So the same philosophy that we had discussed in unit testing can be utilized here. The thing is, try to choose boundary values. So we had discussed in unit testing the concept of boundary value analysis and equivalence partitioning. Same thing is applicable in this case, that is, try to extract the data values in the boundary region, in the mid region. Okay, so as we had discussed in unit testing, try to pump as many values as possible to the shared memory. In case of a shared memory between two components, try to observe the behavior of the shared memory when it is full. Try to study its impact on the component in that case. Okay. Try to push as many messages as possible, as many parameters as possible, and try to see the behavior of the interface. Try to study the behavior of the interface. Okay. See, these are a few strategies we can use for interface testing under component testing, because as already explained, we cannot have an exhaustive set of test cases here. So we will choose boundary values. We will try to bombard the components with data. We will try to fill the shared memory with data. We will try to fill the interface with the data, and we will see what will be the behavior of the component, behavior of the interface. So in these type of cases. Okay. So this was the second one, that is component testing. Now coming to the third part. So the third part is system testing. So in component testing we understood what exactly is a component. Component is a collection of smaller units which are related to one another, which are performing similar actions, similar tasks. So you are grouping it and you are making it as one component. And in a typical software, you will have hundreds of thousands of components depending on the complexity of the software. It is not like 2, 5, 10 components. So hundreds of thousands of components will be there. Okay. Components are not independent units. They should interact with one another. How they interact with one another? It is through interface. So if you want to test a component, okay, if you want to test the behavior of a component, maybe as a single unit or in a group, so you should do interface testing. Okay, so that is what we dealt with in component testing. Basically, it's all about interface testing. Okay. So different types of interfaces that can exist between the components we understood, and also what to check in those interfaces. Okay. So typical clues regarding that were given, and what strategies you can have for component testing as part of the test cases. So that was explored. Okay. Also we understood typical errors, common errors that can occur in the interfaces, and how to resolve it. So these things were explored. So this was component testing all about. So next we will go into system testing. So what is system testing? How exactly it is done? So coming to the system testing part. So we are in development testing. We understood what is development testing and how exactly it is planned and how it is done. Okay. Basically, development testing is done at different levels, starting with the smallest unit, smallest part called as unit testing, and as we go above the hierarchy, okay, the size is increasing, meaning that smaller units combined together became a component, and components combined together will become a system. Okay, so basically in system testing, you are testing the system as a whole. You are combining all the components and you are trying to verify the behavior of the system. Okay, so this was for today's session. We will continue with system testing in session 4. So thank you.